Good day everyone, I am Irma Jane Pagaura. In this video, I will be explaining and proving the linear Diophantine equation. So allow me to start. The simplest linear Diophantine equation takes the form ax plus by equals c, where a, b, and c are given integers. So for example, 2x plus 3y is equal to 20. We also have 2 times 7 plus 3 times 2 is equal to 20. Also, we have 2 times 4 plus 3 times 4 is equal to 20. To know what sort of integral solution we have or what is the result based on linear Diophantine equation, we have this theorem that states linear Diophantine equation does have a solution if and only if D divides C. So there's a condition on if and only if divides C, this linear Diophantine equation ex plus by equals c has a solution, and if ax plus by equals c has a solution, then D is the GCD which must divide C. So this must hold the second implications we wanted to show that if x naught and y naught is any particular solution of this equation, then all the other solutions are given by this expression. So x is equal to x naught plus b divide d times y is equal to y naught minus 2 divide d times t. And d is integral, so a and b are picked up from this coefficient and x and y, and we know that is d. What is d? So d is the GCD of a and b, and what we know as the CC is the right-hand side of this equation. Now let's prove first this implication if and only if, and when we will come to this result for finding all the other solutions of the Diophantine equation. So now in the proof, first I want to go for this implication if and only if. And even in this, let me assume that ax plus by equals c. Then admits a solution, so let's consider the solution x naught and y naught. So suppose that these are the solution. This means ax naught plus by naught equal to c. So we need to prove that D must divide C, and D must divide C, and what is D? We already know what D is, the GCD of A and B. So whenever D is GCD of A and B, so we know D must divide and B must divide B. And I can also write A is equal to dr and B is equal to ds. So just substitute the value of A and B. In this case, we know that C is the same as A. A is dx times x naught. Plus what is the value of B? So I'm just substituting the value for B, and this becomes dA times y naught. Take D common, so these r times x naught plus s into y naught. These are all integers. D of course is an integer, but we can see that D comes as a multiple of D. So this implies that D divides C, and that holds our condition we wish to prove that D must divide C if this admits a solution. Now, conversely, I want to take that gives is D divides C, where D is the GCD of A and B. So this is converse, and we want to prove that ax plus by equals c. These have a solution, so we want to prove that it has a solution for some x naught and y naught. So now, whenever D divides C, we can say that as D divides C. So whenever D divides C, so we can say that as D dash C. So from here, I can write as dy for some t belongs to integer. And we also know that D is the GCD of A and B, so this is given to us. So this implies D must be written as a linear combination of A and B. So let's write D as ax plus by for some x and y which belongs to integers. So we can take this x naught and y naught belonging to integers for this relation holds. So I'm assuming that for some x and y naught for which D equal to ax naught plus by naught. This relation holds, so we have particular values. Now, once we know that D is equal to ax naught plus by naught, it holds for the particular values of x naught and y naught. Multiply t by both sides, so this becomes at at x naught plus bt y naught. And we already know that dt is same as c, so just replace this by c. So we get c equals a. Now get this t with x naught plus b times t y naught. So this means c is equal to ax dash by a c is equal to ax dash by dash. Here x dash is to x naught, which belongs to integers, of course. Y dash, which is also t times y naught. This is also belongs to integer. So this means now linear Diophantine equation has a solution for this part x naught and y naught. So we say linear Diophantine equation admits a solution for x dash that is equal to t times x naught and y dash is equal to t y naught. Now this x dash and y naught, these are arbitrary. So we can simply say that c is equal to ax plus by, and this admits a solution. So hence this proves the over the if and only if condition completes if and only if condition. So that was all about the theorem of linear equation. Thank you, and may God bless us all.